So there's one more abstraction I'd like to introduce before we keep going, and that is the abstraction of an accelerator. So our problem is we have a lot of different methods of acceleration and no real way to codify them so that we can use them easily. For instance, we have gravity as an acceleration force as a way of updating velocity. We have friction as another way of updating velocity. We have constant, and it could be either positive or negative. Say we're walking left, we'll have a constant negative acceleration. If we're walking right, we'll have a constant positive acceleration. And then also we have a zero acceleration. So we have all these different types of accelerations that are a little bit more involved than just simply multiplying the acceleration times the time and then adding it to the velocity, such as in the case of friction. So the solution I have thought of is to use an accelerator struct. And this is just going to have one method, an update velocity. It's going to be pure virtual so that we can override it in all these different types of accelerators. So we'll have a constant acceleration, a constant accelerator, a gravity accelerator, a friction accelerator, and a zero accelerator. And then in addition, the bonus to this is map collidable will be able to update velocity as well because we can just pass in this accelerator struct. And yeah, then it just becomes a matter of choosing the right accelerator to update with. And that will clean things up a lot, especially when we add new. I mean, when we first create an abstraction, there's more code, but as time goes by and we add more make use of the abstraction more, then the abstraction becomes less code. So yeah, that's it for my introduction. Let's get started. So I'm going to open up accelerators.h and accelerators.c as new files. So accelerators.h and .cc. We'll include accelerators.h, and we will header guard accelerators.h. So we'll just create it real quick. This will be singular construct accelerator, virtual destructor, pure because we never implement this. And then we'll need our update method, so virtual void update velocity, taking in a kinematics, which we'll need to forward declare, as well as a units of milliseconds, so we'll need to include units. So kinematics, a reference to it, non-const, so kinematics, and milliseconds elapsed time, and that'll be pure. So the first accelerator I'm going to create is a zero accelerator. And this will just be an accelerator. Its update velocity method is not going to take in any parameters. Well, it'll take in parameters, but it won't use the parameters. And it'll just have an empty implementation. We don't need a destructor, but I'm going to make a static variable because we really only need one zero accelerator. So I'll make a static const zero accelerator, and then we'll call this k0. And let's go ahead and put this in our CC file so that it has a place to put the memory. And it'll go right there. So that is it for the zero accelerator. Next, let's create a constant accelerator. So this will be a lot like the zero accelerator, except it will actually make use of the kinematics and elapsed time. So it'll be the first real accelerator we use. So const accelerator, and we'll need to take in a couple parameters. First of all, what do we need to know? We need to know what our acceleration is. what the max speed is. And then finally we need to know, because we need to know whether to use standard min or standard max, what direction the acceleration is in. So this we can figure this out from using less than 0 or greater than 0. And yeah, since we have a separate struct for ZeroAccelerator, I think I'm going to do it that way. So we'll just do a constant accelerator that takes in an acceleration, and a velocity max speed, max velocity. I'm going to have it contain the sign in it, so I'm calling it max velocity. And let's just initialize some private data to be that. So let's copy this. Give it our underscores and then initialize them. Max velocity gets max velocity. Okay, so now let's implement our update velocity inside of our accelerators.cc constant accelerator. Basically what we're going to do is, if acceleration is less than 0, otherwise we will do the other thing. And let's look at our player class, because View Solution Explorer, that got closed on me. Well, I mean, I probably closed it, but if we look at update X, we'll see how it works. So we use the standard max if we're going to the left, and standard min if we're going to the right. So standard max, so we'll need to include a couple of things. First, let's include kinematics, but then let's also include algorithms so we can get at standard min, standard max. So standard min, this will be standard max, and this will be kinematics. Okay, so kinematics dot velocity is equal to the standard max of kinematics dot velocity plus acceleration times elapsed time. It'll be the standard maximum of that and our max velocity, which, remember, has the sign inside of it. And then otherwise we're going to use the standard min. And that's pretty much the only difference. I could use like some sort of function pointer to reduce this boilerplate a little bit, but I'm not really worried about that. So the next thing I'm going to do is create the k-gravity constant accelerator. So I'll just make this a static field constant accelerator. I'll actually make it constant, or const, and it'll be k-gravity. Again, we'll need to put this in the CC file up here. And in order to initialize it, we're going to need the variables from inside the player class. So those two variables are k-gravity and k-max speed y. So I'm going to delete them from our player class. And it'll break some things, but we'll fix them later. And we'll kind of know when things are done that way. And instead of calling this k-gravity, I'll call this k-gravity acceleration. Oops. K max speed y. This will be k terminal speed. Oh, I forgot to scope these in, so let's do that now. So that's that k gravity is going to need the k gravity acceleration and the k terminal speed. And that should do it for that. Player is going to need to be able to see k terminal speed when it creates one of its accelerators. So I'm going to make that xturn, or just create an xturn here. Xturn const. Why don't I copy and paste? So terminal speed. And this just makes it visible to the outside world, so anyone who includes accelerators.h can see k terminal speed. Alright, so what's next? The next thing I want to do is accelerators that can go either positively or negatively, and this is just going to be a combination of two accelerators, two constant accelerators. So we'll do struct by directional accelerators. And it's really just going to have two structs, but it's going to create it from one. So constant, accelerator, positive, and negative. And both of these are going to be public. It's just a way of constructing them easily and storing them together. So it'll just take in a units of acceleration and a max velocity, like our const accelerator. But it'll just create two accelerators from it. So it'll take in acceleration and max velocity. So it'll take in positive, we'll get acceleration and max velocity, and negative, we'll get negative acceleration and negative max velocity. And this is for walking. It makes it easier to have these two just lumped together. So that takes care of that. And then finally we have friction. So let's look at how we do friction inside of our player class. So let's go down to where we use k friction, and it is just this right here, and it depends on the direction of velocity. So I'm actually just going to copy and paste that in a minute, because I think we can really benefit from copying and pasting. So let's create a friction accelerator. We're going to need to take in a friction value, and I think that's it. So let's change this to units of acceleration for friction. And let's store that friction. And then finally, we're going to need to create update velocity. So let's go into accelerators.cc, and right here above our constant accelerator, let's create our friction accelerator. And now is when I'm going to copy and paste and just kind of go through a little bit at a time. Okay, so instead of kinematics x, it's going to be kinematics. And then instead of k friction, it's going to be our friction, which gets passed in. And instead of elapsed time in milliseconds, it's just elapsed time. So let's see if this looks right. So kinematics velocity is equal to, if the velocity is greater than 0, then it's the standard max of that minus friction. Otherwise, it's the standard min of this plus friction. Okay, that looks good to me. Let's build this. Player CC should break, whatever. What's accelerators? Oh, I see. I copied and pasted too much. So let's change this to friction. VFT. Now it should be happy. And it is. So that takes care of all of our methods of acceleration. So let's put them to use inside of our player class. So let's start by declaring some accelerators for us to use, and let's include an accelerators. So we're going to have a k walking friction, so k friction accelerator, how about that? So const friction accelerator, we'll call it k friction accelerator, and it'll just use k friction. We're going to need to create a bidirectional accelerator for walking, so const bidirectional accelerators, and this will take in, we'll call this k walking accelerators, and this will take in walking acceleration and k max speed x. Next we'll need jump gravity accelerator. So const, this will be a constant accelerator, a lot like our gravity accelerator, except okay, jump gravity accelerator. It'll use the jump gravity. Okay, jump gravity, and it'll use the k terminal speed still, which is now inside of our accelerators.cc file. I think that's all of the accelerators that we need to create in order to implement everything. So let's go down to update X and update Y and use these accelerators. Let's start with update Y. It's a lot simpler. So update Y is just going to check to see which accelerator to use based on this right here. So what I'm going to do is I'm going to create a reference to an accelerator, and I'll just call it accelerator. And this is going to, we have to set it right away because you can't reset references. So if this is the case, if that is the case, then we want to use our jump accelerator. So we'll use k jump gravity accelerator. Otherwise, we want to use k gravity accelerator. So that is going to be in accelerators.h. Where did we put it? Constant accelerator k gravity. So this is basically doing the same thing. Now we need to just update our kinematics. So let's do accelerator dot update velocity, giving it the kinematics y, as well as our elapsed time in milliseconds. Let's build. This should build. Initializing cannot convert. Oh, okay. So we got to make this const. My bad. And actually, let's make our update velocity const too, because this really shouldn't change our accelerators at all. And then that should build. Why not? Oh, I gotta put constant here too. Sorry. This should build and run. I'm just gonna check. He fell to the ground just fine. There's our jump velocity. There's our short jump, long jump. Sweet. So our kinematics has been successfully, our kinematics Y has been successfully abstracted, our accelerator for that. So kinematics X is a little bit trickier, but it's still not too bad. So let's go to update X. Basically what we're saying is, and I'm just going to write it out in the pseudocode, if acceleration, how about this? If on ground, if acceleration is equal to 0, then we want to use our k friction. Otherwise, we use our k walk accelerators. I'm talking about which accelerators we need to use. Otherwise, else, we are not on the ground, so we need to check to see if acceleration is 0. Then we want to use our k0 acceleration because we don't want to accelerate in either direction. Otherwise, we want to use k-air, which we need to create. I forgot to create k-air. And this will be another bidirectional, so we have bidirectional walking accelerators. We also need one for air acceleration. Instead of using k walking acceleration, it'll use k air acceleration. And we'll call this k air accelerators. Yeah, so back to here. So let's go ahead and just get rid of all this so that we don't get too confused. And then just implement it from here. I'm going to make a pointer, so units, nope, that's const, pointer to an accelerator, accelerator, and then we'll just set it inside of a series of statements. So if on ground, else. So if we're on the ground and if acceleration is equal to 0, acceleration x, because remember acceleration x is just a integer value. So if acceleration x is equal to 0, then we want to set accelerator to be equal to, here I'll put parentheses. Accelerator should be equal to k friction, which is k friction accelerator. Otherwise, acceleration x is less than 0, then we want to use our accelerator should be k walking accelerators dot negative. And then finally, is positive. So I'm going to copy and paste this and just switch these out with the appropriate ones. Oh, and these should be pointers, so we'll just use the addresses. So k friction accelerator, this becomes k0 accelerator, which is in ZeroAccelerator. K0. Again, this should be an address, and then this should be k air acceleration. No, k air accelerators. And again, an address. So then now we have accelerator set. We can use it to update our velocity. So accelerator, update velocity, given kinematics x and elapsed time in milliseconds. And this should work. Build. Run. So that looks good, that looks good. Jumping in the air, that looks good. Moving in the air looks good. Dang, that worked out pretty well. So, that being said, let's do one more change, and that is to put the accelerator inside of our update methods, because that is one more level of abstraction that's kind of nice. And that's my sole reasoning. So let's go into map_collidable.h and .cc. We'll for declare accelerator, and we will take in an accelerator, a const accelerator reference called accelerator, just after our collision rectangle, or wherever you want to put it. Let's include accelerator up here after we put them in the correct spots. So let's include accelerator. And then let's update our velocity before we calculate the delta. So accelerator dot update the velocity, giving it kinematics x in this case, and elapsed time. And in update y, same thing except with kinematics y. Now we need to go into player, and instead of updating our velocity, we just pass in our accelerator. For x, we'll need to dereference it first because it's a reference. And then for y, we just pass it in. Build and run just to make sure everything is still working out. Okay, so now I'm just going to say a couple words about why we did this. Because it's all working now, and it's like, it might seem kind of pointless because we just have a player class using it, and like, what the heck, why are we going to all this extra effort? Well, it's actually going to be pretty nice because a lot of enemies and drops use a lot of the same kinematics. So it'll be easy because we can just say, oh, hey, we've already figured out all that kinematic stuff. Let's just use the code we've already written, and that'll all be in those kinematics. And for example, a lot of enemies respond by, are responsive and affected by gravity. So and that's going to be really nice to have just k gravity instead of creating gravity every time and that kind of stuff. We just pass in k gravity to our update x and update y, and bam, or just update y. Sometimes update x. But anyway, yeah, so it's basically a way of, like, a lot of enemies, a lot of drops are going to be able to use our kinematics, and it'll really clean things up and make things easier to build later on. So a lot of work up front, but saving a lot of time down the road and a lot of heartache down the road. So thanks for watching, guys, and happy developing.